Thank you so much. You're very kind. Hello, everyone. This program is called a Geospatial View. And here to weigh in are Brian McClendon from Uber, Jane Macfarlane from here, and Christian Sanz from Skycatch. And here to lead them in discussion is Robin Murdoch, our valued collaborator who, in fact, first suggested this topic. And then finally, we want to thank Julie Rosendahl and Accenture for enabling this gathering tonight. Thank you. In case you're meeting Churchill Club for the first time tonight, we are a 30-year-old tech and business forum that is always reaching for what's new, next, not widely known. So we are very interested in topics that seem ripe for opportunity, that are not already overly discussed, so that we can get at some new insights. We are a nonprofit, and our mission is to encourage innovation, economic growth, and societal benefit. So we are seeking to illuminate new insights for the people in the room. We always respectfully ask our speakers not to pitch, not an issue with our speakers tonight. We have 7,500 members, and we present up to 30 programs each year. And by connecting people with ideas in one another, people with juice and motivation, like the people in this room tonight, it is our hope that something good can happen for you, just as it has for so many others over the past decades of these gatherings. So we do invite you to join and participate if you're not a member. Please do check your programs and churchillclub.org for a list of upcoming programs. And people asked me to mention, because it got through the grapevine, that we are doing a program this week at the Oracle Arena with the president and COO of the Golden State Warriors, Rick Welts. And then we get to watch the much anticipated game with the Spurs. Unfortunately, it is sold out. If you're tweeting, please use the hashtag Churchill Club. And now let's bring up Robin, our moderator, who founded and leads Accenture's Global Internet segment, and he devotes himself to helping tech and internet companies to capitalize on the changing digital landscape. Please give him a very warm welcome.
Thanks. Thanks very much, Karen and the Churchill Club, for organizing this event tonight. So our discussion this evening is on geospatial technologies that increasingly form the underpinnings of lots of our digital experiences. They're the really obvious ones, like the mapping applications you have on your smartphone, to ensuring search results are more relevant and location-specific. And there's also things like commercial use in logistics and construction. And as we look forward with geospatial, though, there's lots of exciting new technologies where geospatial is going to really underpin the experience. Things like autonomous vehicles, and indeed, as we lean more into the future, augmented reality. So it's a time of incredible change and opportunity. And we've got three fantastic speakers in Chris, Jane, and Brian. And so I'd like to welcome you onto the stage, and then we'll have you introduce yourselves. Great. So as you're getting set up, so Christian, why don't you introduce yourself, what you do?
Hi, everyone. First of all, thank you so much for having me. Third time, by the way. I work at Skycatch. I started the company about 3 years ago. We build drones, and we work with really large construction and mining companies to optimize their workflow on a daily basis using data.
Jane.
I'm Jane Macfarlane. I have been in the vehicle business with General Motors, which got me into the mapping business. And I have a background in high-performance computing, and my PhD area was in artificial intelligence and dynamic systems and controls. I work for HERE, a mapping company, formerly known as Navtech, as well as some other piece parts that came together to build a mapping company that goes from content all the way out to your device. And for those of you that might have seen it in the news, we've recently been purchased by a consortium of companies, 3 of which are BMW, Audi, and Daimler. And we are going into a whole new era of location cloud services, which will be very interesting.
Great. Brian.
Hi, I'm Brian McClendon. It's good to see so many people who love mapping as much as I do. I grew up my career did in Silicon Valley working for Silicon Graphics as an electrical engineer, but that actually led to a very interesting 3D development that became Keyhole and then Google Earth. And so we were acquired by Google, and I ran the mapping business for Google for 10 years until last year, at which point I joined Uber, where I'm responsible for maps and the self-driving and autonomy work.
Great. It's an amazing panel. I think you'll all agree. So normally with the Churchill conversations, we like to really sort of look at the future. But geospatial is such a broad and complex topic. I actually want to start with kind of the history of geospatial so we can all get grounded on your experiences. So how did we get to where we are today? Maybe Jane, start with you.
Yeah, so it's kind of an interesting progression that's happened. When I was at General Motors, I worked at OnStar. So OnStar was kind of the first scaled delivery of telematics. And so it was very exciting that we had the opportunity to get this information in the car. We had no bandwidth at all. And so that's what's really changing here. That got me into the mapping business. And mapping has changed dramatically. It's gone through such a transformation. Think about in 5 short years ago, we were delivering maps on hard media at a quarterly cadence. And now we're updating maps in real time. So the maps are very complex data products that require you to conflate thousands of different sources of information together, along with rules and constraints about how to build a consistent quality map. So that's where the 30 years of experience that HERE has come into play, is you learn those rules and constraints as you build those maps. And you learn all these issues about how to make a very high quality map. And that is just the content part of making maps. So very complex data objects, and getting even more complex now, because now with the digital capability that we have, we're layering all these annotations on top of those maps. So it's not just the road network, it's not just the administration areas anymore, it's buildings, it's restaurants, it's transit systems, it's all the things that are happening in real time around your local space. And that gets you into this very kind of large data management world, confused even more by geospatial connectivity. And then what we really need to do is bring it down to you. So we have to slice out of that big data the contextual information that you care about. So a very challenging computing environment informed by many, many years of making maps.
Brian, your
Yeah,
thoughts?
so definitely making maps is very hard, and I came at it from satellite imagery and sort of the almost infinite resolution you can get from pixels, but there's no information content necessarily behind those pixels, certainly not in the early days of satellite imagery. But at Google, we added map layers, actually licensed initially from Navtech in the very first versions of Google Earth and Google Maps. But one of the things that we discovered is that there's both business risk and technical challenges with not controlling your own data, and Google decided to make its own maps over time. And as you saw, the experience when we started Google was MapQuest-like, where you would say, I want a map, and 20 seconds later they would render a map, and it would be very nice, and it would have been rendered on, online, but you go scroll over 20 more seconds. And so Google Maps' claim to fame was really that we just pre-rendered all the tiles and then set them up for you so that when you panned, it was there seemingly very fast or instantly. And that was the initial value there. But then we realized so many people were using it in so many different ways, it became embedded in millions of websites around the world through the Google Maps API. And this need for our own data led us to make maps in a faster, more cost-efficient manner than happened before because there were advantages. And we used Street View to make the maps and to improve our data, and basically built out over 60 countries worth of data over time. And we also use user-generated content. That was another thing. There's a product called MapMaker that was actually the source for some of the best maps of India and probably 20 or 30 other countries where basic mapping just wasn't there. But that was kind of the steps up to now. The making maps and making more accurate maps has been a very hard technical problem. And now that we have more imagery, we can actually extract information from it. And I think you're going to see a lot of fast-moving, improved maps just on the base layer in the future. We'll talk about more complex maps soon.
Fantastic. And Chris, you've fascinating. You're getting stuck into the construction space, the mining space. You've seen that world change that's allowed your company to exist. Maybe discuss that.
Yeah. I think the beginnings and being sitting right next to you guys is actually such an honor. Why am I here? Just kidding. We collect data, but we basically use maps to extend the map itself. And what we've learned working at Skycatch is, mining companies, construction companies, more and more they're looking for ways to advance, the construction methodology and get it to move faster. And what we discovered working with construction companies and mining companies is that visibility is what gives you the ability to move faster. The ability to say, make decisions based on what you see. And, at the very basic data set, we've achieved that with a lot of companies. But what we've seen starting last year, we've seen something beyond that. We've seen companies wanting to, now that they see the data, wanting to automate machines, wanting to, now that we have visibility of the real-time world and XYZ in the space and everything, now we can actually do other things, not just inform humans, but we also can inform machines so they can do things. So that's where things got really interesting for us.
And also, but there's also been the trend around digitization of the construction process.
That's right.
That's played into.
Yeah, that's another angle that we didn't see. When I started the company, and I told you my story, I was at the 49ers Stadium when it was being built, and I went in there without a hard hat, and I got kicked out. I was starting the company, and I had a drone, and I went in there again. I waited for another security guard to not be there, right? And I went in there again, and I actually mapped the stadium. That's when I came in, I saw the stadium. Wow, this is incredible. Brings me back to the early days. Now companies like DPR are utilizing creating 3D models and designing in real time. Be able to change, if you go back like 5 years ago, to be able to change things, you had to know exactly what it looks like today. So if you have a design, you want to be able to change the structure of it. You want to know exactly what it looks like today. We enable that today. So the design, the in-process design is enabled by having visibility into the real world. And that's what these tools are able to do.
Right. So maybe switching gears, let's talk about what it takes to build a global mapping data set, the enormity of that task. I'm struck that there aren't that many companies that can do that, can take that on. Brian, the effort involved, give us some sense of what it takes to get to 60 countries.
So it takes many different things. It takes sourcing those thousands of data sets that are already out there. In the United States, for example, the government has the Tiger data set, which is a fine road network to initialize from, but it's actually nowhere near professional quality for what we need, but it's a good start. And that's true kind of throughout the world. There's always sources for data that you need to start with, but then you need to improve it. And whether it's the geometry, the addresses, or the geocodes, address ranges and things like this, all need correction. And so the way that Google approached it actually came out of the Street View work. So we had been driving Street View as a consumer experience where we were just taking pictures and publishing them in like 5 cities in the US in 2007, and realized that we could start to make maps from that data, but you needed very high coverage. And we ended up driving on the order of 90% of all of the roads in the United States. And over time, the reports now are that on the order of 35 million miles have been driven in Street View. And that imagery is great for consumers. You get to preview where you're going to go, but it's also very useful for making maps. And one of the things that we started with was humans we'd start with OCR. We'd try to do that old style optical character recognition and extract the street numbers and address numbers. And that would only work for about 35%. And the rest of them, we would send the thing that looked like a number to a human, and they would type the number in. And they were very fast at this, and we did a lot of them. And we did a lot of it internally, we did it externally with Mechanical Turk and things like that. We ended up with about 2 billion of these, which helped us have very accurate address geocodes for Google Maps. But in 2013, I believe, an intern applied Google Brain to this problem and took the 2 billion truth sets where the humans had confirmed it, applied that to the imagery, and trained a system that is now more accurate than any two humans and is able to do that whole process automatically. And so what you'll see, I think, as deep learning gets better, as imagery gets better, that much more of this will be automated over time. And this will help because the problem now is less about making it the first time than it is about chasing changes. And so chasing the dynamic world is the last goal of mapping. For years it was just we were wrong in so many ways it didn't matter. But the closer you get to perfection, the more people are unhappy when you make a mistake.
Well, when I first got into mapping, I realized immediately the challenge with mapping is you don't know what you don't know because you were just there yesterday. The Starbucks burned down. You even have an image of the Starbucks there, but it burned down. So one of the challenges now that the timescales have changed, that we're trying to capture reality, and that's going to get even more challenging with automated vehicles and the like, is that you have to do multiple channel sensing. And so, we already do that with all the information sources, but crowdsourcing, every channel you can possibly get, you need to bring in and conflate to give you better information with some level of probability that it's correct. And that's the challenge, because now you've got people intermixing with information sources, which are typically wrong anyway. they're old, and you've got all these different kinds of sources of information that you have to pull together. And now what we're seeing coming with the automated vehicles and unlocking all that data out of vehicles is you've got the beauty of vehicles is they got a big battery in them. And so they're devices that can deliver really rich sensing information. And that is what we see going forward with our new owners, is that part of that consortium agreement is they are going to be bringing vehicle data up into the map for real-time updates. So that's very exciting.
So as you look at you gave the example of the Mechanical Turk moving to automated. What's the role of the human in creating mapping data sets? And I suppose, what's the role in humans working for your companies, but also the role of me as a user giving you feedback? How relevant is that?
So I mentioned MapMaker before, but I think that that's when it's you actively are interested in making the map and you go create maps of your neighborhood and you're very proud of generating the maps. But there's also all sorts of both active and passive behaviors of users. So users, when they use Google Maps or any mapping service these days, has the opportunity to report a problem. And they can do it a couple of different ways. They can just say, this is wrong, which is very barely useful. Or they can say, here's the correction and edit, and I'm pretty sure it's right. And so if that user over time is trustworthy, you can just take that change if it's a low priority feature. And the challenge there is really knowing whether you can trust a user's change or not. And of course, if bad users want to manipulate the map, you need to have all sorts of machine learning to detect what kind of users you can trust and which ones you can't. And that's been one of the challenges, I think. When you have too much user input, you have to filter it down. But the other side of this is passive. And as an example, Uber drivers have their app on all the time, and so those GPS points actually give Uber a lot better feel for both the accuracy of the maps and the patterns of traffic And things that are not on the map today, like what are the best pickup and drop-off points, because at the end of the day, the most important thing to Uber is maps, and sort of the most important part of the efficiency process for us is meeting between the rider and the driver as quickly and accurately as possible. Because how many of you have had to call a driver and explain to them where you were right now? And
I did.
yeah, and so maps or lack of good maps or lack of good use of maps are almost always the cause of that. And so if we can get a better mapping service and better mapping experience, then hopefully in some near future it will be a seamless roll up to your doorstep kind of experience at all times.
I was just saying, I was in LA this weekend and I asked for directions to Universal Studios, and not any of your products told me to go to Florida, which not the most direct route. So Christian, one of the fascinating things about Skycatch is that refresh, how often you can refresh, is you bring an ability to provide visibility so frequently. How does that impact your customers, and what are you seeing? Are they wanting more and more refresh data? What does it allow them to do?
That's a great question. It ties a little bit about on what you just mentioned, the data, the mapping data, because it's not current. You end up with situations where you're in the wrong spot and you have to call them, and I do that every single day, by the way. Just wanted to let you know. On our end, we started off with, look, we're giving you incredible data. And in all honesty, a lot of these companies where we don't need this data every single day, give it to us every month. And we've been working with some very interesting clients where we basically just gave them the data every single day, and they became part of their process every single day. The challenges that we're going through today is they're coming back to us is that the data is not given to us fast enough. Can you figure out a way to give it to us fast enough? And now we're building technology to do data processing on board the UAV, so that as soon as it lands, the data is available to you immediately. It's just it's interesting to see how quickly the human goes from, okay, now it makes sense. I can tie that into a workflow. Now I want to do that immediately, and it's forcing all this evolution on the technology side.
Right.
Yeah.
Right. So that's kind of like where we are. Hopefully we've covered where we are today, and you're going to have time for questions. So if I've missed anything on where we are today, you feel free to ask. But let's sort of move to right. So where are we heading? In speaking to you all, there's lots of talk of us being at an inflection point with maps, that we're needing to move to the next level. Can you, Brian, talk to us about what we mean by HD maps and beyond, and how that differs from what we understand maps to be and what you've just described?
Well, actually, maybe Jane can probably answer, since you're selling HD maps right now, and so I think we'll start there.
Okay, Jane.
Well, so yeah, we're moving from a map for a human being to use and to do basic routing to a machine-to-machine environment, right? So then you need centimeter level accuracy. We have vehicles that go out just like the other mapping companies do, with LiDAR and imagery and IMUs on them to map the city streets. So it's an entirely different representation. And the important thing is it's going to be used for highly assisted driving as well as automated vehicles. So if you think about an automated vehicle, it's perception and control. It's a robot. And then I really need, and so it's got all these sensors, and you need to think about the fleet as another sensor that comes back into that vehicle and provides the other vehicles in the fleet are providing real-time information into that perception and control system. So it's an entirely different animal altogether. And it's very big data when you're working with LiDAR. And you need to do lots of feature extraction to understand what the elements are in the urban environment. And it's an entirely different kind of data processing system altogether.
Right.
But the important part is this fleet now as a sensor system. That's entirely new. That means that if you're in a lane and a lane has just been closed off by Caltrans, if we have a large enough fleet, that information can get back right away to all the people behind it. So think of all the safety impact we could have with that. It's just a whole new way of thinking about traffic and the dynamics of, the basic mobility of cities.
So I would extend it in the sense that HD maps in some ways are the precise lane markings and the very detailed geometry of the roads, which is something that maps of the past did not have. Then there's what autonomous vehicles actually need, which is something much more than that, right? The goal, the best you can have is a perfect understanding of all of the physical world around you, both the geometry of it and also the types of data, the semantic understanding of it. And there's 3 applications of it. One, and the most important one, is localization. Where is the car exactly? And not just is it near this lane or that lane, but where is it oriented? Exactly how fast is it going? And doing all of this without GPS, because there's no guarantee. You might be in a tunnel, the GPS might be not working. The car still has to know exactly where it is, which means it needs effectively a very detailed feature map of the world around it that is recent, such that you can localize yourself. The second part goes to identifying all of the data in one of these maps, is that computers on cars, even the best ones, are not smart enough to look at everything in the world and wonder, is that a human? Is it going to move? They don't know. And so the best thing you can do is to have a picture of the static world, that part which is not changing, and identify, this is the grass, that's the curb, this is the fire hydrant, it's not going to move, the light is not going to move. And so subtract out all that is static, and then let the computer go figure out for all of the other objects, what are they, and are they heading in my direction, could they head in my direction, and then make predictive and planning based on best knowledge. And if you're not sure, the car has to be careful. And you start to hear about autonomous vehicles being too careful, and that's because they're not sure about what they're identifying and they're playing it safe. And the better they can understand it, the smoother the experience will be.
Right. And Chris, your data is allowing construction companies to allow autonomous vehicles in construction sites. Can you talk about how your technology enables that, and how it differs actually from what Brian's just described?
It's related, actually. The high fidelity of our data is giving the ability for other machines to completely autonomously move around and do the things that you typically do with someone inside the vehicle. For example, a bulldozer or an excavator. And looking at it not as a business, it was very interesting. Even seeing it operating when we were in Japan, and seeing the whole thing, live, is a little bit surreal. And imagining what the world would be, 5 years to 10 years from now, when all of it will be automated, and looking at the positive side, not the negative side, but a lot of companies are thinking about that now that they have this high fidelity data available in real time.
So what does it mean to a construction site when you can, automate?
I mean, for us, it's a little different because we don't think like a construction company.
Right.
We enable them, and they do things faster. But we look at the entire world, and we think about like World Bank donations to South America. When they put $1 billion worth to build things, they can build a lot more with $1 billion at that point. Roads, homes, all kinds of things. That's the way we look at the world, and when you look at the automation of these things.
Right. Jane, you talked about you started to talk about the taxonomy of mapping, the layers. As you look to the sort of new world that you're moving into, how does that taxonomy change, and is it settled? How is it evolving?
Well, how does it change? I think it's just getting richer. The scale of what we can do now is completely different than what we used to be able to do. So what we can embed in this digital structure is just a lot richer information that will be valuable to you contextually. So it's really growing from that perspective. It's not just a road network anymore. it's bike paths, it's trails, it's all the things that you want to do in your everyday mobility needs, and it's able to engage more because we have the networks and we can get data from all these devices. So it's really coming into, you know, from a content service now into, you know, really enriching every app. And I would suggest that, you know, we use maps all the time. We've been making maps since the dawn of civilization. It's a very, very rich part of how we operate as human beings. You know, we educate, we communicate with maps. And they're just getting even more rich as we are able to layer those things on.
So, Brian, with Uber, you know, it's no secret that you're looking at autonomous driving and various technologies. As you look at the technologies that enable that to happen, the hardware technologies, what are things being built on? What are the technologies you need to be able to move to autonomous driving?
I think the most important ones are computer vision and LiDAR and the ability to get this much higher resolution data. So LiDAR is laser distance range finding, and it helps to very quickly scan an area very high resolution distance-wise and some pixel resolution. And this allows you to generate these point clouds that can then be turned into feature maps that can then help you with that localization I was talking about. So LiDAR is expensive. Typically, you know, for the spinning ones that you might have seen on some cars, $64,000 for 64 lasers was a price that was very common. But there are a lot of technologies on the horizon that are going to bring laser costs down, and some interesting companies and some interesting takes on it. The video and camera side of it, you know, cameras are getting better, but the most important thing actually is less about the cameras and the compute behind it, because with all those pixels, it's very hard to learn things from it without having a lot of onboard computing. And so some of the challenges that have been had there, you know, actually happening just across down the street is GPU Tech, which is NVIDIA's GPU conference. And it turns out that one of the big things that's happened in technology has been the introduction of low-cost GPUs in high volumes with deep learning networks in the car. And so they have announced products like their Drive PX2, which is a pair of GPUs on a board that can go in a car with sensor inputs, you know, all packaged together. So they're, you know, driving from their angle very hard on this path, but the costs have come down a lot, right? You could not have possibly have gotten the compute necessary in a car until the last couple of years.
So what's going to be done in the cloud? What's going to be done in the car? How's that going to play out?
So the challenge right now is that you know, nobody is completely successful at autonomous driving. There's still learning going on. There's a lot of improvements happening. To do that, you need to collect a ton of data, create those maps, but maps are only part of it. It's actually much more the experience that the car sees. So all of the sensors the car sees need to be recorded and then uploaded, and then all of the software needs to learn from all of the situations or all of the pictures, and you can use deep learning to train the car to better recognize pedestrians, bicyclists, motorcyclists, cars, the direction of cars. All of this helps when you have enough input that you can then again send it off to a deep network to train, such that you pull back this trained network that you can then run on the car. And so this sort of circle of collecting huge amounts of data to train a network to then run live for live reactions is sort of the big churning engine of improvement in autonomous vehicles. And it depends on good compute in the car, but it depends on huge compute in the cloud and huge amounts of data, anywhere from 30 gigabytes an hour to a terabyte an hour of collected data. And, you know, what are you going to do with that? You need to churn through it.
You mentioned, you know, GPS might not be available, connectivity might not be available, and actually the data, the size of data you're talking about is going to be challenging to get up to the cloud, I would imagine.
So yeah, getting up that much data up to the cloud is very much a challenge. And so what you typically would do is you would get the very interesting, concerning bits up through some very narrow channel, and then you would then usually, I guess, take hard drives out of the car and stick them into a hard drive plug and then churn it off at, you know, gigabytes per second, right. And then put a new drive in and let it go driving again. And so that's part of the learning process. So I think the production side of AV in the future probably won't do that. But in the training world that we're in right now, that's critical. And that's going to be critical for all the cars that are doing this in the early days, is they need to collect those hard samples that help train the system to get it better, because it's a long haul to make high quality, safe AVs.
Right. Yeah, I totally agree with that. It's a long haul. And I would suggest that, I was in high performance computing in the DOE National Labs years ago, and when distributed computing started, heterogeneous computing. And it took us 15 years to get tools out to use the compute power. And I would suggest that right now we're going into kind of a new era of geospatially distributed computing, which is completely different. The way you create an app is going to be completely different if you have compute power in the network itself, as opposed to the cloud, as opposed to on the device. So where does the compute happen and how does it come together is going to be a very interesting ride. And the deep learning is kind of the first part of the gathering, and then the next phase is kind of the semantic understanding of what you have. And that's another piece of the autonomous vehicle progression, is that they can't look in your eyes, so they can't determine intent. So there's all this semantic level thinking about, if I see a ball roll in front of me, I stop maybe because of the ball, and maybe I start to go, and I need to know that there's probably a child coming behind it. So that higher level representation of the reality, we're not there yet by any stretch.
How are you balanced, Chris? How are you balancing between the drone and your cloud? I mean, how's that?
Well, I'm thinking about, like, as I hear, I never put into context or imagine like the magnitude of data that you have to deal with. And we don't have to deal with that much data. We deal with very picky customers and single job sites. And for instance, some of the things we deal with is you need to remove objects from the ground. The terrain needs to be clean. The point cloud needs to be clean. Cool, we can do that. We can do that for 30 job sites. But now I'm imagining doing that around the world. Mm-hmm. I'm like, oh, I need to call you guys.
You're doing more processing actually on the drone, though, aren't you?
We never imagined that would be something that we had to do. The minute people started applying, the data to certain daily functions, they became almost addicted to it. This had to be done faster, and that put pressure on us to actually go out and put the onboarding processing rather than doing it in the cloud. So transferring the data from the UAV to the cloud, we went through using Wi-Fi to using a data card, having a cell phone basically on the drone itself, to testing which one is a variety of different solutions. And now we're moving towards actually doing onboard data processing, optimizing the file and sending that to the cloud instead. But it goes back to the same thing. Once you give a human data and they apply that to something valuable, I can get from here to someplace else. Now they want it faster, and we're going through that experience. But I never really thought the magnitude of dealing with that a million or a trillion times like you deal with.
So back on the autonomous vehicles, we're self-driving technology. So Uber already has autopilot rolled out onto a fleet of end users' vehicles. How useful is that data set relative to the data set that you might collect from your own vehicles?
You probably meant Tesla, I think.
Tesla, I meant Tesla, sorry.
Yeah,
Good correction. Tesla's got the autopilot. Mm-hmm. So how useful is that kind of data set, or the data set that you actually create yourselves with your own vehicles, with your own LiDAR sensors, et cetera?
Well, I think for Tesla, that data is probably useful, and I think how they use it and what they get out of it really depends. The challenge with customer vehicles, though, is that the data that's collected, whose data is it, right? And what TOS did you sign and so forth. But I think that, in general, when you're building a system, you need to build it with the sensors that you're going to deploy, and so I'm sure that's what Tesla's working on.
Jane, what about the feedback loop from? So you have fleets of vehicles that are collecting data. How much does the end user data play into improving?
It certainly plays in. Again, I think we're trying to capture reality. That's what you always have to think about in maps, is I'm trying to capture reality right now. So fleets are important, particularly because they can collect these huge point clouds that you probably won't have on your vehicle at home. But so they are a part of the collection process, but you need to have the other fleet. And that's why this consortium actually came together, is to have a fleet of the size that you can actually capture reality. And that's why it's an open consortium, so that other OEMs can join, so that we can have that coverage to get that reality feedback. And vehicles will have different levels of sensing and feature extraction, et cetera, coming back in. And your devices, even if it's not a vehicle, will also be doing the same. So it's a multi-channel problem and a sensor fusion problem that's of great scale. And one thing I did want to say, though, is that as this vehicle data starts to stream in, there's a lot you can learn from it, even if you're not building an autonomous vehicle. There's a lot of things you can do from a safety perspective with it as well. So, for example, you can learn from the wisdom of crowds, if you will, how people experience the road network. And if you have that information, you can then layer that on top as another annotation on your map that can help people who are inexperienced at driving what to do, or tell them what to do. And teenagers, they say, that it takes a human being about 10 years to learn how to drive, to really learn how to judge things. And imagine a teenager with an experienced driver with them at all times, which is very possible from just taking the sensor data in and learning from how we experience the network. So valuable safety things can come very soon from vehicle data, even though autonomous vehicles could be kind of far down the road.
One thing that I just want to add to that, I always thought that in the future, 5 years from now, even sooner, that all cars will be aware of each other. So, drunk driving or car accidents won't be as often because they'll be aware of each other. It won't be necessarily autonomous driving, but it's just aware of there's something moving in my direction that's a car, like you mentioned earlier.
So I think, that the levels of autonomy that are defined, ADAS or automated driving assist system levels, there's 1, 2, 3, 4, and 5. The level 1 is kind of in the neighborhood, maybe level 1, level 2. Tesla's autopilot is very nice, but it's still, I think, technically not quite level 2. Level 3 is where the driving is good enough that it can drive itself, but it will then tell the human, I can no longer handle it, so you have N seconds, 15 seconds to take control of the vehicle, which that would be awesome if it was that good. And then level 4 is the much more interesting one, which says that a human is not needed, but may have a lot of ancillary data requirements and mapping data requirements to do it. And I think there's a mythical level 5 or 6, which is, can a car without a map be as good as a human is at driving a road it's never seen before? And right now, I don't think anybody is aiming at that problem. But humans can do it. Even teenagers can almost do it. Not with high safety, but they can get there. And so that the challenge is, even the best thing we're aiming for is still, in some dimensions, not as good as what a human can do, but in many cases is good enough to be far safer than the 30,000 people who die on the road each year, half of them due to drunk driving and 94% due to human mistakes, 1 million per year worldwide, right? There's a lot of things that can be prevented even if we're not ready to, take on an unknown road.
One thing I read, I don't know if this is true, but I read a report about that autonomous vehicles, if it gets spread out, and you have 90% of autonomous vehicles out there, that it has a chance to reducing traffic, for instance, because everything is coordinated.
There's a lot of paths to doing that. I think that one of the things that Uber's doing with Uber Pool is to promote more sharing of vehicles, and that is actually the goal, to get those human drivers actually taking care of this problem in the short term, where riders are going in the same direction, and if we can make the right connections in the Uber service, then we can take a material number of cars off the road. And I think we're definitely seeing that in many of the cities where Uber Pool is deployed. We're taking significant numbers of cars off the road, and Los Angeles being one of the bigger cities, but cities in China and San Francisco, it's a very, very successful path. But in the future, then autonomous vehicles might be bigger, and you might have different sizes based on the path they're going, right? Big buses are not the best way to carry people most of the time. And so if you were smarter about packing your people, you could actually save a lot of energy and actually reduce traffic.
And in addition, I just want to add, you can also pack the cars.
Yes.
And so in Europe, that's what they're interested in, is that everybody gets packed in very nicely, and
Moving it
kind of
at
the
the same
elevator
speed.
ride that we all do, is that the vehicles will be doing the
Not
same.
stopping for some random stuff
Yeah.
on the side of the road.
Right. But the one thing about the pooling and the like is that's something that we all need to think about, is how cities will change, because the dynamics of people's mobility is going to change dramatically, and also the infrastructure required to do it is going to change. So as this is something that we need to step back and think about from an urban planning perspective, is as we're trying to push people into EVs or hydrogen, where does the infrastructure lie? And that we now have basically on-demand dynamic transit door to door. And how will that change the mobility of a city and the design of a city? It's going to be a very interesting change.
So when vehicles are shared, then there's actually fewer vehicles in the city, and 20 to 30% of the real estate in most cities is wasted on parking. And if you could cut down the actual number of cars that go into the city, then you can recover that land and actually answer your question about where to host all those electric charging stations. But I think that will be a big impact on cities and city planning, because I don't think there will be that many cars in cities 5 or 10 years from now.
Great. So we promised we'd also talk about augmented reality, which might seem like how is that related? But it's very related, that finer grained view on the world. Brian, do you want to start, and we can...
Right, so I asked to talk about this a little bit. I think that the maps that we're creating for self-driving cars are these very detailed, precise geospatial maps. Augmented reality and virtual reality, for those who don't know, virtual reality is Oculus Rift and this HTC Vive, the Google Cardboard. You basically put a screen in front of your eyes and you're living only in that world. And so it turns out that virtual reality can work with a relatively imprecise map, because you're just looking for self-consistency, but you don't know about how it relates to the world, the real world. Augmented reality is a different experience. It's still a headset right now. Microsoft Hololens is the example that most people might know about, where it draws things in front of your eyes, but you still see the world around you, and it's adding things to it. And so HoloLens today can map a room and put something on a table and give you sort of the experience of a computer-generated object that is locked down to that table. But its world is very small. The real destination for augmented reality, and this is still several years in the future, is where these glasses that I'm wearing are good enough that they can drop down and layer on information that is exactly tied to the world around me. But the challenge with that is it has to know the world around me at the same level of detail as autonomous vehicles do, so that when it labels the building over on the side of the road in English as I walk down a Chinese road, I can understand and navigate the world around me. That kind of extra information that allows you to understand the world around you requires this very high resolution map, because if it's off by a little bit, it's going to look terrible. And if you don't understand exactly where the glasses are looking, it's going to make you sick. And so the challenge of getting that high resolution geospatial map is going to be the sort of, in my opinion, end game for the augmented reality applications.
Agreed, as usual. And can think about the windshield of a vehicle as also a place for augmented reality. And when you, again, it's the same issue, this very high level precision of reality that you have to register to. It's all about registration. Even building the high definition map, it's all about registration because I am user imperfect. So you drive one direction and you get an understanding of reality, and by the time you come back, your understanding of your position has drifted a little bit, and you have to re-register these giant point clouds. So it's a lot of heavy data lifting, and then add the complexity of registering these other things on top of that is very, as you said, if you get it wrong, it's very bad. And I'd also suggest that the user interface on this stuff, if it gets into vehicles, is, you know, it's fun to see a little character on the table there, but if I'm going to interfere with your driving process, then you have to be very careful how you deliver that information to the user in the vehicle or the driver in the vehicle. Maybe when it comes to automated driving, we won't care anymore, but in the short term, if we start trying to do this, we have a challenge to keep it safe at the same time.
In our world, just because I'm a software engineer, so I have my own Oculus, so I play around with it at home, and I'm always trying to figure out an excuse to bring it into the commercial world, and I have to bring back myself to focus. You know, keep it simple. But you know, the way I see it is the more we enable being able to digitize the real world, the real-time world, the more we can interact with it from any place in the world and make decisions around it. And it's not just drones, but all sorts of technologies are able to do that. But the photogrammetry behind that is extremely complex and still not there when it comes to being able to do that really quickly. But you know, we're getting there so quickly. It's fascinating.
Okay, so a couple more questions, and then we'll open it up to the audience. You know, you've already touched on sort of the societal impact of some of these technologies. What are some of the things you're really excited by that the advances in geospatial technology will allow over the next few years?
Being from kind of the AI world, I think this whole notion of autonomous vehicles mixed with human drivers is going to be a hugely interesting problem. And so what we're really talking about is human agent collectives and building incentives into the agents to operate appropriately in the collective. And you know, maybe someday we'll get to fully autonomous if you build your infrastructure so that you separate the world. But that is going to be a really interesting problem, and driven by that semantic understanding of the reality that these humans and agents are operating in. So very interesting work to be done coming up, I think.
There's so many different directions to go. I'm actually going to go a bit backwards and say that maps as we know them today are not yet perfect. You know, I would say if I had to give examples, the United States, the UK, Japan have really strong maps, both historically because of, and also culturally, the focus there. Many other countries, not as good. And one of the advantages of all these new technologies is actually to bring other countries in world maps up to the level of quality that the UK and the US and Japan have been living with. And that changes things about how the country operates. And there's like material impacts on GDP for, you know, if India had, you know, accurate geocodes and accurate house locations and didn't spend all their time literally driving up and rolling down the window and asking, how do I get to this person's house? Because that is how navigation is done in many parts in India, because they didn't, you know, either name the roads or don't have the good maps. So interestingly, the collection of user-generated content has greatly improved maps in India, and drivers are beginning to trust maps more. They're not yet fully there. I think the maps are a bit ahead of the trust, but there's still so much more we can do. And then the reverse of that is the closer you get to perfection, the more people trust the maps and stop caring about them. And that maybe this is, you know, the dark side, but if you make mistakes, you know, people will fail. And so we've had a couple of examples at Google. In 2010, Nicaragua invaded Costa Rica because there was a border that was not quite in the right place, and they used Google Maps as their excuse for the invasion. And now,
your fault.
Yeah, they blamed it on us, and I think it was a convenient thing on their part. But the reason was that we had sourced our border data from the most trusted source that exists, the U.S. State Department. They've promised I would never say that, but that's where it came from. And it was a small mistake, and we quickly corrected it. But clearly, people can use maps for the wrong purposes. But even last week in Texas, after some tornado damage, a demolition crew went to a house and tore it down, and it turned out the geocode was wrong, and they'd torn down the wrong house. And this is in using maps that are quite good but not quite perfect, and so you should always double check your maps. But as the maps get better, people trust them more. And one of the challenges, though, with adding all of these layers of data is that unless the data layer is comprehensive, like covering a city or a country, then it's very easy to add a little bit of features. But if you want all of the walking maps or all of the indoor maps, that is a really large, hard problem, because each of those is reaching deeper into resolution. And so we've seen interesting experiments with indoor mapping. Google's done several, and other companies have done it as well. And it's really useful, but it's not complete yet. But once we have these new technologies where mapping can be effectively passively created based on sensors that are walked around in your cell phone or in your glass or whatever, then building these maps and making them accurate will be, I think, an easier challenge, because it will be more about compute than about collection.
And Chris, I read about some really interesting things you did from a relief perspective in Nepal. Can you talk a bit about that?
Yeah, I mean, we when the Nepal earthquake happened, we flew in the next day. In fact, Eugene, sitting right there, who's the first guy who flew into Nepal, not really knowing exactly what our role was going to be in Nepal. All we knew is we have these photo gathering things. If we can rescue one person, that'll be enough for us to be happy about. And we told the team, hey, who wants to volunteer? And pretty much everybody volunteered. And so we flew in, and of course, I was terrified because I'd sent people in, and if something happened, it's on me. And so when we got there, immediately we were contacted by UNESCO and the World Bank. And the World Bank immediately asked us for information about schools and also hospitals, to give them photogrammetry and maps on them, because they can analyze it and figure out how much funds they can deploy. And we never even thought that that was actually a use case. We immediately, in fact, Eugene and another pilot went out there and did the processing, and that enabled and unlocked $5 million. We have no idea that was delayed, only because they didn't know exactly what the extent of the damage was. And we were able to provide that immediately. Wow. And also with UNESCO, they're having the challenge of having to rebuild all of the heritage sites in Nepal. And that's like an 8-year project. What they're realizing now, that they're trying to collect imagery from Instagram, from Facebook, to recreate all of these heritage sites. Right. Now what they want to do is work with us and other drone companies to digitize all heritage sites around the globe, so that they can have and they're going even further out to save that in a black box somewhere in case of a massive, disaster, or so they can recreate, or future generations, they can recreate these monuments. It's pretty impressive.
So actually, I was going to mention photo reconstruction is something that is, I think, advanced huge amounts. We've seen crowdsourced collections of images. Google has clustered lots of POIs, photos together, and actually regenerated 3D models from just those kinds of photos. And if we have enough photos of some of the destroyed ones, you might be able to have an accurate 3D model of what something looked like, even though it's already fallen, as long as there were enough pictures taken in the past, and then you can access them and put them together. And so there's been amazing things happen the last few years, and it's, I think, get even more automated as we go through.
So, final question. You've all been involved in this space for a while. 5 to 10 years from now, what will we have solved? Where will we be with mapping? Will we have solved autonomous driving?
No.
You will not have solved autonomous driving for every place in the world at all times. I think there will be autonomous driving happening in certain places at certain times, and the definition of certain is the most interesting question, I think, on the table.
Right.
You know, working with construction, I mean, some of our clients, we realized that, you know, giving them this high fidelity data, we're so ignorant as to how much you can do with it, because they come back to us with things that we can't even imagine. But we just give them this canvas, and here's the canvas, and then they are the ones to associate that with real things they do on a daily basis. So the way I look at it, what fascinates me is, like 10 years from now, real-time data everywhere of 3D, of 3D, you know, and I can't even imagine the data processing challenge for that, right? You know.
Well, yeah, and that's kind of the vision of the Here cloud, is that this is a place that's independent of hardware and OS. It's an independent, open ecosystem where everybody can contribute. And so imagine if everybody's contributing and the amount of information that you can get to enrich your mobility decisions and your view of the world around you. And again, I think that, you know, it can be used for so many good causes. But even for us, you know, that map now becomes our advisor. It's not something we consult anymore. It's advising us. Go down the street to this bus stop because there's less people there, or except there won't be a bus stop. There'll be an Uber car there, an Uber pool car. It will just be an entirely different animal in our lives. We won't be doing this anymore.
Right. Great. Well, I think it's time for questions. So, first question, please.
Hi. So, as sort of a layman, I follow maps, and I love Google Maps and all this other stuff. I tend to think of it historically as just satellite imagery and just better and better resolution. But I'm listening to you guys. I'm thinking these flying cameras are going to be obsolete pretty soon because you're talking about point clouds and the LiDAR and all this really, really precise, high-res stuff. So have we got it wrong, the people who are all excited about satellites just because Google bought a satellite company and there's great press around some others, or because you guys have so much other technology to choose from, or is there something that, are they still unique? Do they still bring value, and how do they stay relevant?
So I think that the combination of all the different data sources that Jane mentioned, satellite imagery is one of them. I mean, one of the challenges in mapping in the large is that the world is physically changing. And the coordinate system that we use to describe the surface of the Earth, it's not a sphere, and it's an oblong sphere. But worse than that, it's on tectonic plates, and they shift. And there are actually different coordinate systems for the different tectonic plates. And if you don't understand that, and you map your data, you end up with shifted data. And Google Maps actually found that problem with some of the high-resolution aerial imagery when it was projected into the wrong mapping space. And so part of how you create maps is this sort of base of the world stitched together. And so initially, yes, there's low resolution satellite data, high resolution satellite aerial imagery. The resolution's getting better. The goal is to put that together into a single picture, and that's kind of Google Earth's reason for existence, is to try and unify that into a single image. But it's still the basis for how we create maps, right? Here uses satellite imagery to make sure that things are aligned and organized, and updates to it are actually very interesting. So some of the high frequency updates we're seeing in some of the new satellites, Planet Labs is talking about daily updates of everything if they get enough of these tiny satellites up there. Google bought Skybox, which is a different take on a similar problem, fewer satellites but much better resolution. And then there's the digital globes of the world who have very expensive satellites and take pictures frequently, but they cannot possibly visit every city every week like Skybox is talking about. And that dynamic data is interesting, as Christian's company has discovered, for narrow use cases, but it's also interesting in the whole world. And so processing large amounts of changing Earth data is one of the goals of this product called Google Earth Engine. And it started out with Landsat, which is free but low resolution. And Skybox is kind of the next set of that data, where instead of 15 meters once a week or month, it's going to be 0.7 meter data once a week for every city in the world. And when you can start to do interesting scientific temporal analytics on data, you can learn things about the world that are far beyond the maps that we have today.
We learned the movement of the Earth in Japan. I never thought I had to deal with, Earth is giving me a challenge. Moves a centimeter every once in a while.
Yep.
So, and I would just add, that it's a sensor. So, I think very simply, I've got all these sensors and I've got to put them together somehow. And my sensors have temporal, they have timestamps on them. So, whatever I can get from the world that will help me make a decision about what reality looks like, I'm going to use it.
Great. Next question.
I'd like to bring it a little further back to today. Your customers, your end users, have got problems, today's problems they want solved. What problems are they bringing to you that you have not yet figured out how to solve? Question make sense?
Yes, and there's so many to choose from.
Yeah, I know. I was like, where do we start?
I mean,
Yeah, if you ask that to an engineer, you typically get like, let me figure it out.
Start with the one that's the most urgent from the customer perspective.
In Uber's case, it's the rider and the driver connecting with each other as quickly as possible. And that last level of detail on the map and that last level of correct position for each of the two so that you can describe the connection point accurately. And so one of the things that Uber's done to try to address this is we have this idea of hotspots, where when you say I want to be picked up in a building in a city, there might be this one location that is the easiest for drivers to get to, that matches the traffic pattern, that is where the driver is headed anyway, and you can direct the person to walk around the corner and get a much better and smoother pickup than if you try and pick them up, let's say, on Market Street, which is just not a good idea. So that would be one of mine.
Yeah, I think governments have a lot of questions about mobility that we don't have enough sensing information today to answer. So we can answer speed questions, but we can't answer flow questions. So there's, excuse me, I think there's a lot of issues today of not having penetration of sensors in the world. And that's one of the things that I think will be very exciting about the fleets coming from automakers, is your penetration rates get really high. So, so that's one of them. And of course, the HD map is something that we're all working on right now to get to highly assisted driving, at least.
I have a couple of challenges on our end. One that we're actually solving, but maybe 6 months ago we were completely unaware of how to get there. But being able to get 2 centimeter resolution data on the ground without really laying out foundation or GCPs, on the ground as reference points to do the photogrammetry. That adds a tremendous amount of work for some people on the field to actually put reference points on the ground. So our clients were basically asking for, in order for us to scale, we need the ability to get this data without us being involved in the process. And we were able to solve that by working with RTK antennas that are already available everywhere, and triangulating the GPS data that we got from satellites and using the RTK antennas to triangulate and get the 3 centimeter data. It took a lot of work, and I think that maybe 2-3 weeks ago, it was the first time we got 2 centimeter data all the way across the entire field, which is pretty amazing. And we probably are the only company doing that today. The challenge that I think that big companies will be able to solve is being able to do like that level of computer vision and data processing for the ag business. The ag world can really use a lot of help in optimizing their crops, but there isn't a lot of margins to pay companies like us to do that kind of work. So, and you're talking about 30% of the world, putting it through photogrammetry to optimize. In every single region, you optimize it for the weather, the bacteria, or whatever they want to optimize for. That is a challenge that I think Skybox is trying to solve, or Google, or so I heard. But it's going to be challenging.
Great. Next question.
Yeah. Jane, you kept mentioning everyone, everything, shared, and then Brian, you threw out the term kind of thrown away, depending whose data it is or who owns it. Can you just speak to mapping data, taking it out, and whether it is an issue of privacy or for the greater good?
So, I should be very clear that if automakers are giving their data, they are definitely managing privacy and security. And all the data that we get today, as far as dynamic data, is anonymized for privacy. The challenge with this this whole new world that we're in with devices everywhere is, so Internet of Things with vehicles all coming together to try to create a holistic view of the world, is all of those devices have different characteristics. And that is one of the big data analytics problems that we have, that we're facing right now, is where did that data come from? What are the characteristics of it? Because I can only use certain data for certain things, and I shouldn't be using fleet data from big trucks for something associated with consumers, for example. Or I shouldn't be using consumer devices to maybe understand road networks better, because they can walk through parks, and they might give me and I might think there's a road there and there isn't. So you have to understand where the data comes from. And then I think one of the bigger challenges is quality of the data. So these devices don't work a lot of times, or they're duplicating data, or something's broken on the sensor on the device, and so you're getting bad data. So when you have a giant bucket load of data, how do you do quality checks in large data sets like this? And it is, I think, a very interesting topic of research, because we are right now, we're armed and dangerous not in here, out there.
Hopefully not.
Not in here. We're quality controlled, but out there, we're getting large amounts of data, and we have all these amazing tools at our fingertips for anybody to work with. And you can take all this data and generate nothing if you don't understand what you started with and where it came from, and where it can go wrong. And I think right now we're in this happy zone of, oh, data good, right? And all the developers and data analytics people are just happy as could be. And I think that's also coming from AI, when AI was first out. We went into the winter, and now we're back out of the AI winter in the machine learning, deep learning, and everybody has a machine learning sticky on their forehead right now. And you can generate really bad results by just using the tools out of the box without understanding it. So I think we've got a lot of work to do around that side of the problem.
Next question.
Are there technologies that are adjacent to autonomous driving vehicles that may have fewer regulatory or liability restraints and might evolve quicker, and perhaps give us a preview of where the technology is going?
I mean, on my end, Komatsu is automating in bulldozers, and they're operating within a private area. So you don't have any sort of really big restrictions. In fact, there's no restrictions at all, especially in Japan. So I think that in job sites, you're going to have a lot of that flexibility.
I think, for years now, there's been work on automating snowplows in whiteout conditions using high accuracy GPS and haptic control systems and things like that. There's systems out there that help bus drivers drive along the side of the road at, when they're in deep traffic. So there's lots of technologies being deployed now, and a lot of the autonomous vehicles, the activity is going into controlled environments right now, retirement homes and campuses and places where they can control at least most of the environment. They still can't control the people and the other good things that confuse vehicles, but autonomous vehicles. So I think we will definitely grow that direction.
I think it's hard to learn a lot. I mean, I think the campus style is probably the closest. The challenges of on-the-road driving, there's not a lot of good analogs for it. And, you know, I think maybe you can improve perception, the recognition of the objects in the view, but at the end of the day, the planning and all of the scenarios is really just going to be a large-scale data collection problem, and you need to be on the road with humanity driving to see, just to experience it. And I think each of us has had our own personal driving experiences, and that's how we've learned to drive ourselves, but you need much, much more of that collected before we'll have enough data to, I think, teach, you know, computers to be safe enough of the time.
Brian, you gave that example of the honey bucket, recognizing where we were speaking earlier. You know, is that if you're a Google self-driving car, you need to know that someone might be coming out of.
Right. Yeah. So basically, in my examples before, like a fire hydrant or light post, those are pretty easy. But if it's a porta potty, it looks solid, stable, but somebody could pop out of the door and be walking right in front of you. And so that is, and this is an example Google used yesterday, so it's not original, but it's a good one where you have to plan for all sorts of incredibly unusual scenarios, and you know, we are always trying to create new and harder problems to throw at the system to see whether A, they can recognize what's going on, and B, they can plan correctly for all of the possible outcomes, and that's a nearly infinite space.
Right. Next question.
Question for Brian and Jane. There were a lot of rumors when HERE went up for sale from Nokia that Uber might have been bidding for HERE, for those maps. Obviously that didn't happen. Jane, you would have done well to have had this large fleet of probes going out there, of Uber vehicles. Would have been nice perhaps to have that data. And Brian, I have the feeling maybe you're going full circle where you might have to start now by licensing HERE data like you did many years ago at Google. But eventually, you're probably going to build up your own data set. And I'm sort of curious about that. Do you plan eventually, or are you planning to license data to start with, Brian, and eventually to develop your own data set? And Jane, how much does it hurt to lose that? You've got the OEMs, those are big fleets, but there's a lot of privacy issues around using those individual vehicles. So I'm curious about how different is the world today since the auto OEMs, some of them, picked up HERE as opposed to Uber?
I mentioned some of the tougher questions might come from the audience.
Yeah, there's a lot packed into that, and I think just so one tactical admission though is that Uber had actually licensed TomTom data, which is the one competitor of HERE, and that's actually one of the challenges in the marketplace. Is there are really only two places that you can go to buy data, which is TeleAtlas, which is now TomTom, and Navtech, which is now HERE. And so that led Google originally to make its own data, but Google does not sell its data, so it's not an option. And so I think there was a decision made, and we're working on using TomTom data to improve the service. We're using many different map sources and services because we want the best things for our customers, but we need sort of a base map at times to improve things. But as to what was happening back in the bidding days. Pass.
I'll pass on the bidding part, but so the one thing to remember that what we do, we provide services on top of the map. So we actually, we provide a traffic product. We have predictive traffic product, in fact. So we already source lots of data from lots of different places in order to produce that dynamic representation of traffic. So the vehicle fleet that's coming in, again, they will manage the privacy. It's their fleet, they'll manage the privacy. And they will, offer anonymous data to enhance our understanding. That data is going to be much higher fidelity than what we get today. So we'll have sensor information if we need it, and we'll have, we could have, if we wanted it, which I hope we don't, as millisecond level data, right? So we mix 5-minute sampling frequencies with 5-second with millisecond data. And so we have that data already, and now it's just going to be enhanced that much more. And you guys are welcome to send your data to us as well.
Great. Next question, please.
It would be very kind of you.
Thank you for a very interesting talk on maps and map making. This question is for Brian. I just spent 10 weeks in Bangalore and used Uber every day multiple times. You brought up a very interesting point about the challenges that you have, the customer and driver connectivity. We had to call the driver at least 3-4 times every time we ordered a cab. And there was one instance of one building where they would be consistently across the road in a highway. So I'm wondering if you can talk about the challenges of using Uber in Bangalore. Culturally very different in some ways, and yet there are a lot of similarities.
Mm-hmm. Yeah, I think the challenges with any country that hasn't had even the basic road networks correctly and completely mapped, which I think, as I said, as we approach perfection, any mistakes there. But the U.S., UK are doing pretty well. India is still earlier days. When the network isn't right, then we're going to direct people on the wrong path, perhaps, if we base it on that map. But there's actually a different problem, which is that there's not always a clear definition of where here is. You described you were at a building and would go across the street. Well, typically, in India, people like to talk about landmarks. And so one of the things at Google we did was actually to try to populate Google Maps with as many of the visually recognizable landmarks as we could to try and improve the directions for maps. And using those and saying it's not just 300 meters down the street, it's past this landmark that we seem to think is visible for plus 50 meters is a much clearer information because you can see it in the distance. But none of that matters if the map is not accurate. And I think the challenges around the world are making the maps much more accurate than they are now. And I think that all these sensors that Jane is collecting and that perhaps we're also working with can help improve that and hopefully get a faster and more direct connection. But there's still the social element that you have to trust the maps. And without that trust, you'll always have them rolling down the window and asking for directions. Yes?
In one instance, the drivers all trust the map. In one instance, the driver was driving down the wrong way. It was a one-way street. He kept going down the wrong way, and he ended up getting caught with the police and paying a fine. And he trusted the map completely. He said, Uber map tells me to go this way.
Yep. Plenty of work left to do, but I would say that India drivers are more aggressive than any I've seen. My experience in India was actually that it was a two-way road, but it was separated, and the driver couldn't figure out how to get to the entrance to a building, so they actually went over to the other side and drove up the opposite way on the edge of the other lane. And the struggle there is now, let's say we collected that sensor data and used that to correct the map. We would then claim that suddenly you could go both ways on both sides of the road. And you can go downhill very quickly if you are not smart about how you use data in correcting maps.
Okay, we've got time for one more question.
Hi, I'm wondering what are some of the challenges faced and how do you address concerns of privacy? And I understand the situations of blurring out a face or a license plate, but maybe at a higher level where governments, businesses, or individuals don't wish their property to be mapped for potential subversive uses.
So we allow people to take whatever they want out of the map. I mean, if you go to Germany, most of the street level imagery has a lot of people's homes blurred out. So it's up to whomever. There's a lot of government installations that aren't mapped. There's lots of parts of countries that aren't mapped. We don't map the whole world.
So I think that mapping as much of the world as possible is important.
Right.
But there are certainly categories. I believe we called it blurminy. That where privacy is very important, and they literally had buildings blurred out in the Street View images that did get published. But there are also government restrictions depending on what government it is. But satellite imagery is actually almost entirely immune from that. But street level imagery is certainly not. And so you won't find street level imagery in India and China, for example, which I think is unfortunate, but it is part of the national security that they follow, is that they don't want to enable anything by having well imaged ground level locations.
For us, since we're collecting real-time data maybe a year and a half ago, every single company we work with, they were very concerned about privacy. And if we collect data from their private location, we needed to blur out everything else. And that was the case a year and a half ago. Today, not a lot of people are asking for those things. It's sort of weird how we evolved from that over time.
Interesting. Karen.
All right. On behalf of everyone in this room, thank you so much for sharing your perspectives. We really appreciate it. This has been a wonderful conversation. We do have a small gift for you. It is the Churchill Club speaker t-shirt. We hope that you wear that safely and in good health. And a recording of this program will be available on our YouTube channel, hopefully tomorrow. There are recordings of most of our other programs as well, and we hope that you will find that to be a very useful resource. You will find some real gems there, I can tell you. And you have been a wonderful audience. Thank you so much. See you next time. Good night.